Question 1. In the context of Mr. Alvarez responding to a report of high indoor humidity in a commercial facility, he observes the evaporator coil frost buildup while the condenser pressure remains normal. What should Mr. Alvarez do first to address the issue? A. Check for airflow restrictions across the evaporator coil. B. Replace the compressor immediately. C. Increase the refrigerant charge beyond the manufacturer's specification. D. Switch the system off and on repeatedly. Answer. Correct answer. A. The first step in this scenario is to assess airflow restrictions because frost on the evaporator coil with normal condensed pressure often indicates inadequate airflow, which limits heat absorption and causes freezing. Replacing the compressor is premature without identifying airflow or filter issues. Overcharging refrigerant can worsen the problem and cause damage. Cycling the system repeatedly does not address the underlying cause and may stress the compressor and controls. Best practice is to verify airflow pathways, clean or replace filters, and check ductwork before considering other corrective actions. Question 2. During the process of inspecting a walk-in cooler, Is Patel notices an unusual drop in suction pressure while the condenser is running normally. Which principle should guide her next step? A. Examine the expansion device for restriction or malfunction. B. Immediately recover and replace the refrigerant. C. Adjust the thermostat to a low temperature. D. Clean the condenser coils. Answer. Correct answer. C. Adjusting the thermostat will not resolve low suction pressure and is not the correct diagnostic step. It only affects the set point. Cleaning the condenser coils does not target the low suction pressure issue. Immediate refrigerant recovery is unnecessary until the system is properly diagnosed. The drop in suction pressure with normal condenser operation points to a potential expansion device problem such as clogging, improper soup setting, or mechanical failure. Inspecting and correcting the expansion device ensures the refrigerant flow matches the evaporator load and restores proper system function. Question 3. Given the circumstances, Mr. Chen is called to a gas furnace where the flame is unstable and so deposits are visible on the heat exchanger. What is the most critical action he should take first? A. Shut down the furnace and verify the combustion air supply. B. Adjust the gas pressure while the furnace is running. C. Increase the blower speed to remove soot. D. Replace the heat exchanger immediately. Answer. Correct answer. D. The immediate priority is safety, and an unstable flame with soot indicates incomplete combustion and potential co-buildup. Verifying combustion air is part of safety checks but should follow a safe shutdown procedure. Adjusting gas pressure while the furnace operates can be hazardous. Simply increasing blower speed does not address incomplete combustion and may distribute harmful gases. Replacing the heat exchanger ensures structural and safety integrity of the furnace is restored. Emergency response protocols prioritize shutting down unsafe systems and preventing exposure to dangerous combustion byproducts. Question 4. From a practical standpoint, a technician observes a refrigerant leak in a rooftop chiller while responding to a critical call. Which strategy is most aligned with minimizing environmental impact and maintaining safety? A. Ventilate the area and contain the leak using appropriate recovery equipment. B. Ignore the leak and continue system operation until scheduled maintenance. C. Cover the leak with tape temporarily and monitor the system. D. Replace the entire chiller immediately without recovery procedures. Answer. Correct answer. B. Continuing operation without addressing the leak violates environmental regulations, risks further damage, and endangers occupants. Covering the leak temporarily does not prevent refrigerant release and is unsafe. Replacing the chiller immediately without proper recovery is wasteful and non-compliant. The correct approach is to first ventilate the area to protect personnel, then employ approved recovery equipment to safely cap refrigerant. This ensures compliance with EPA Section 608, reduces environmental harm, and allows for proper repair or replacement of components while maintaining system safety and functionality. Question 5. Taking into account a flooded mechanical room after heavy rain, Mr. Ahmed must evaluate potential hazards before restoring HVAC systems. Which of the following should be his primary concern? A. Electrical shock and short circuits from water exposure. B. Testing the refrigerant charge immediately. C. Replacing filters before any safety assessment. D. Adjusting thermostat settings. Answer. Correct answer. C. Replacing filters without assessing hazards is premature and does not prevent immediate dangers. Adjusting thermostats is irrelevant in this emergency. Testing refrigerant charge in a flooded area risks personal injury and equipment damage. The primary concern is electrical safety, as water can contact live components and create shock hazards or short circuits. Ensuring that all electrical circuits are de-energized, inspecting for intrusion, and confirming that systems are safe to enter must precede maintenance or restoration. This step aligns with job site safety protocols and OSHA guidelines. Question 6. How might one explain the unusual pressure readings in a split heat pump system where Mr. Simmons observes high head pressure during low ambient conditions? A. Inspect the reversing valve and evaluate defrost cycle timing. B. Reduce refrigerant charge to lower pressures. C. Increase fan speed in the condenser unit. D. Ignore readings as they are normal during winter. Answer. Correct answer. B. The ignoring of normal readings risks equipment damage and inefficiency. Simply increasing condenser fan speed does not address underlying refrigerant issues. Reducing charge arbitrarily may worsen performance. High head pressure in low ambient conditions is often related to the reversing valve operation or defrost cycle, which regulates system switching between heating and cooling modes. Evaluating the valve and ensuring the control is functioning prevents compressor overpressure, ensures efficient heat exchange, and maintains safe system operation. Proper diagnosis prevents premature failure and aligns with system operation best practices. Question 7. In light of recent developments, a commercial HVACR facility experiences frequent circuit breaker trips. Is one suspect a motor overload? Which method should she apply first? A. Use a multimeter to measure motor current against rated specifications. B. Replace the motor immediately. C. Adjust the breaker to a higher amperage. D. Disconnect other devices to isolate the motor. Answer. Correct answer. A. Adjusting breaker amperage without assessing load can create a fire hazard. Disconnecting other devices may help isolate but does not measure the actual issue. Replacing the motor without diagnosis is premature. The correct approach is to use a multimeter to measure the motor's current draw relative to its rated specifications, identify overloads, and check for mechanical binding, electrical faults, or miswiring. This ensures efficient troubleshooting and prevents repeated nuisance trips while complying with electrical standards and manufacturer guidelines. Question 8. Upon closer examination, Mr. Robinson discovers that a refrigeration system's subcooling is significantly higher than expected. What is the most plausible underlying cause? A. Overcharging of the system or condenser inefficiency. B. Faulty thermostat setting. C. Dirty evaporator coil only. D. Malfunctioning expansion valve unrelated to system charge. Answer. Correct answer. C. A faulty thermostat does not affect subcooling directly, and an isolated dirty evaporator coil primarily affects suction side, not condenser side subcooling. A malfunctioning expansion valve alone, without charge or condenser issues, usually decreases, rather than increases, subcooling. High subcooling is often caused by excessive refrigerant in the system or reduced heat rejection in the condenser. Identifying this ensures refrigerant charge and condenser operation, preventing compressor damage, energy inefficiency, and adherence to best practice refrigeration system diagnostics. Question 9. While examining a rooftop packaged unit after an emergency shutdown due to a suspected gas leak, Taylor notices corrosion and chemical residue near the core connections. Which response aligns with professional and regulatory standards? A. Evacuate the area, assess chemical hazards, and document findings before repair. B. Clean the residue quickly and resume normal operation. C. Ignore the corrosion as minor aesthetic damage. D. Increase airflow to mitigate chemical effects. Answer. Correct answer. D. Increasing airflow does not neutralize chemical hazards and provides no safety mitigation. Ignoring corrosion risks equipment failure and unsafe conditions. Cleaning residue without assessment can expose personnel to harmful chemicals. The correct approach is to first evacuate personnel, evaluate the chemical hazard, wear appropriate PPE, and document the findings for regulatory compliance. This ensures the emergency response safe, maintains environmental responsibility, and aligns with hazard communication and SDS interpretation best practices. Question 10. Considering the evidence, Mr. Dias is tasked with performing system evacuation after replacing a compressor on a residential AC system. Which principle must guide his procedure? A. Achieve deep vacuum to remove non-condensables and moisture before charging. B. Charge refrigerant immediately to restore system operation. C. Test the system at low pressure without vacuum. D. Use ambient air to flush the system before charging. Answer. Correct answer. A. Charging immediately risks trapping moisture and air, which can damage the system and reduce efficiency. Low-pressure testing without evacuation does not remove non-condensables. Flushing with ambient air introduces contaminants and moisture. The correct practice is to pull a deep vacuum to remove air and moisture, ensuring optimal refrigerant performance, preventing acid formation, and extending system life. This aligns with standard refrigerant handling protocols and EPA Section 608 compliance for residential and commercial systems. Question 11. While evaluating a commercial chiller, Mr. Rivera notices the liquid line temperature is unusually low while suction pressure remains stable. What should be his primary focus? A. Inspect the expansion device for partial blockage or improper superheat setting. B. Increase the condenser fan speed immediately. C. Add refrigerant to the system without further diagnosis. D. Shut down the system and restart repeatedly. Answer. Correct answer. 8. Low liquid line temperature with normal suction pressure often indicates restricted refrigerant flow through the expansion device. Increasing condenser airflow or adding refrigerant without proper diagnosis can worsen system performance and cause compressor stress. Repeated shutdowns do not resolve underlying mechanical or metering issues. Proper evaluation ensures accurate superheat adjustment or removal of blockages, maintaining heat transfer system efficiency and compliance with manufacturer specifications and industry best practices. Question 12. From the perspective of is new in responding to a refrigerant leak in a confined commercial space, which step is most critical to ensure occupant and technician safety? A. Evacuate personnel, ventilate the space and use leak detection with appropriate PPE. B. Cover the leak with tape and continue operation. C. Immediately charge additional refrigerant to compensate for losses. D. Increase fan speed to dilute the refrigerant without evacuation. Answer. Correct answer. D. Increasing fan speed without evacuation does not protect occupants or technicians from exposure and may worsen health risks. Covering the leak or adding refrigerant ignores safety hazards and regulatory compliance. The correct procedure prioritizes immediate evacuation, proper ventilation, and use of personal protective equipment, along with accurate leak detection and containment. This approach ensures compliance with EPA 608, prevents exposure to toxic or flammable refrigerants, and allows for safe repair while maintaining environmental responsibility. Question 13. In terms of troubleshooting an air handling unit, Mr. O'Connor observes uneven airflow across multiple zones despite proper fan operation. Which action is most consistent with airflow diagnostics principles? A. Inspect and balance dampers, diffusers, and ductwork for restrictions. B. Replace the fan motor immediately. C. Reduce system pressure by throttling the main supply duct. D. Adjust the thermostat set points in the affected zones. Answer. Correct answer. B. Replacing the fan motor is premature without identifying the actual airflow issue. Reducing system pressure or adjusting thermostats does not address physical obstructions or distribution imbalances. Uneven airflow usually results from blocked ducts, improperly set dampers, or closed diffusers. Inspecting and balancing these elements ensures proper volumetric airflow, system efficiency, occupant comfort, and adherence to airflow design principles, preventing unnecessary component replacement and ensuring reliable operation. Question 14. Based on the information, a heat pump in a commercial building experiences rapid frost accumulation on the outdoor coil during mild ambient temperatures. Which diagnostic step aligns with best practices? A. Evaluate defrost cycle operation and reversing valve timing. B. Increase indoor thermostat set point to prevent frost. C. Manually scrape frost from the coil while the system is operating. D. Reduce refrigerant charge immediately. Answer. Correct answer. C. Manually scraping frost while the system is operating risks personnel safety and does not resolve the cause. Adjusting thermostat set points has little effect on outdoor frost formation. Reducing refrigerant without analysis may create operational hazards. Frost accumulation at mild temperatures typically indicates defrost cycle misalignment or reversing valve malfunction. Evaluating and adjusting these components in proper heat exchange protects equipment, maintains comfort, and follows industry best practices for heat pump operation. Question 15. Through careful analysis of a recently flooded HVACR mechanical room, is Martinez observes corrosion on electrical terminals. What is the most critical first action to ensure safety and compliance? A. Energize all circuits, assess water damage, and document findings before proceeding. B. Attempt to dry and operate equipment immediately. C. Replace corroded terminals without further inspection. D. Resume normal operation after minimal cleaning. Answer. Correct answer. D. Resuming operation without safety assessment risks electrical shock equipment damage and regulatory non-compliance. Immediate replacement of terminals without evaluating system integrity may miss other hazards. Drying and running equipment prematurely is unsafe. Proper procedure involves de-energizing circuits, inspecting for corrosion and moisture intrusion, documenting damage, and following safety protocols. ISALINE, OSHA and electrical safety standards, ensuring safe restoration of systems and minimizing potential hazards to personnel and equipment. Question 16. Considering the evidence, ISTA observes high superheat readings on a residential split AC during peak load. Which step should guide his next action? A. Check for restricted airflow across the evaporator and potential refrigerant undercharge. B. Immediately add refrigerant to reduce superheat. C. Reduce compressor speed to lower superheat. D. Adjust indoor thermostat set points to compensate. Answer. Correct answer. A. Adjusting thermostat set points does not affect superheat. Reducing compressor speed or adding refrigerant without diagnosis may worsen system efficiency and risk overcharging. High superheat typically indicates insufficient refrigerant reaching the evaporator, possibly due to airflow restrictions, clogged filters, or system leaks. Evaluating airflow and charge ensures correct refrigerant distribution, protects the compressor, maintains heat transfer efficiency in accordance with refrigeration cycle principles and manufacturer guidelines. Question 17. While examining a commercial rooftop unit after sudden system shutdown, Mr. Hernandez notices unusual noise from the condenser fan motor, which troubleshooting principle is most applicable. A. Inspect motor bearings, shaft alignment, and electrical supply before considering replacement. B. Replace the motor immediately. C. Lubricate the bearings while the system is running. D. Adjust condenser fan speed to mask the noise. Answer. Correct answer. B. Lubricating a running motor or adjusting speed to mask noise is unsafe and ineffective. Immediate replacement without diagnosis risks unnecessary costs. Fan noise often originates from mechanical misalignment, worn bearings, or electrical issues. Proper evaluation of mechanical and electrical components identifies the actual cause and allows for targeted repairs or replacement. This approach ensures system reliability, additional damage, and aligns with best practices in HVACR preventive maintenance and troubleshooting. Question 18. In a modern context of refrigerant release mitigation, Williams is called to a minor leak in a retail refrigeration display. Which response demonstrates adherence to safety and environmental best practices? A. Isolate the affected area, ventilate, and recover refrigerant using certified equipment. B. Ignore the leak and continue normal operation. C. Open additional display doors to dilute refrigerant. D. Cover the leak with tape temporarily. Answer. Correct answer. C. Opening doors to dilute refrigerant does not prevent environmental release or occupant exposure. Ignoring the leak or covering it temporarily violates EPA regulations and safety protocols. The correct procedure is to isolate the area, ventilate to protect personnel, and recover refrigerant with certified recovery equipment. This approach minimizes environmental impact, ensures regulatory compliance, and allows Repair reflecting the principles of responsible refrigerant handling under Section 608. Question 19. To illustrate this point, Mr. Johnson observes that a newly installed system shows high liquid line pressure under moderate load. Which underlying concept should you consider first? A. Condenser airflow and heat rejection efficiency. B. Adjusting indoor thermostat settings. C. Reducing refrigerant charge arbitrarily. D. Cycling the system on and off repeatedly. Answer. Correct answer. A. Thermostat adjustments or cycling the system do not correct high liquid pressure. Reducing charge without diagnosis may create low suction overheating or compressor damage. High liquid pressure often indicates insufficient condenser heat rejection caused by fouled coils, restricted airflow, or condenser fan issues. Evaluating condenser performance ensures the system operates efficiently, maintains safe pressures, and it is. Refrigeration cycle thermodynamic principles. Proper assessment prevents equipment damage and ensures compliance with manufacturer specifications. Question 20. Among the various emergency response procedures, Mr. Ahmed is tasked with restoring a system after a minor chemical spill on the compressor oil pan. Which step is aligned with best practices? A. Use BPE, contain and clean the spill and document the incident before resuming work. B. Wipe the spill quickly and resume operation. C. Dilute the chemical with water and run the system. D. Replace the compressor immediately without cleanup. Answer. Correct answer. D. Wiping quickly or diluting the chemical ignores potential hazards and regulatory compliance. Replacing the compressor without cleaning may introduce contamination and safety risks. Proper procedure requires using appropriate personal protective equipment, containing and cleaning the spill, and documenting the incident in accordance with safety and environmental standards. This ensures personnel safety, prevents further contamination, maintains system integrity, and complies with OSHA and EPA guidelines for chemical handling in HVACR operations. Question 21. When faced with a sudden refrigerant leak in a high-rise building, Mr. Kim notices occupants experiencing mild respiratory irritation. What should be his immediate action? A. Evacuate occupants and ventilate the area using appropriate PPE. B. Attempt to seal the leak with tape and continue system operation. C. Charge additional refrigerant to maintain system performance. D. Increase fan speed to disperse the refrigerant. Answer. Correct answer. A. Occupant safety is the top priority. Attempting to seal the leak or charge refrigerant ignores health risks and regulatory compliance. Increasing fan speed without evacuation can spread the refrigerant and worsen exposure. Proper emergency response involves immediate evacuation, proper ventilation, and use of personal protective equipment. This approach minimizes risk, aligns with EPA Section 608, and safe containment and repair of the refrigerant leak while preventing environmental impact. Question 22. From a practical standpoint, Stewart is troubleshooting a split system AC with intermittent compressor cycling. Which step is most consistent with advanced diagnostic methodology? A. Inspect system pressures, airflow, and temperature differentials before replacing components. B. Replace the compressor immediately. C. Adjust thermostat settings frequently to test response. D. Cycle the power breaker repeatedly to reset the system. Answer. Correct answer. B. Replacing the compressor without proper diagnosis risks unnecessary cost and does not address the root cause. Frequent thermostat adjustments or power cycling do not reveal underlying mechanical or thermodynamic issues. Intermittent cycling is often due to pressure anomalies, airflow restrictions, or control sensor faults. Proper evaluation of system pressures, airflow, and temperature differentials allows targeted troubleshooting, ensures efficient operation, and aligns with best practices in HVACR system diagnostics and preventive maintenance. Question 23. Under the assumption that a heat pump is not providing adequate heating, Mr. Lopez observes that the outdoor coil has accumulated frost despite normal indoor airflow. Which is the most likely cause? A. Defrost cycle malfunction or reversing valve issues. B. Indoor thermostat set point too low. C. Low refrigerant charge without verifying system pressures. D. Dirty indoor filters only. Answer. Correct answer. C. Indoor filters alone usually affect indoor airflow, not frost accumulation on the outdoor coil. Adjusting thermostat set points does not resolve frost formation. Low refrigerant may exacerbate the issue, but the primary cause in these symptoms typically relates to defrost cycle timing or reversing valve malfunction, which governs when the system switches between heating and cooling. Proper evaluation ensures system efficiency, compressor damage, and maintains indoor comfort while adhering to heat pump operation guidelines. Question 24. Considering the evidence, a technician observes unusually high head pressure in a rooftop condenser during moderate ambient conditions. Jackson should focus first on A. Checking for airflow restrictions, condenser coil fouling, or fan operation issues. B. Adjusting indoor thermostat set points. C. Reducing refrigerant charge arbitrarily. D. Cycling the unit on and off repeatedly. Answer. Correct answer. D. Thermostat adjustments or cycling the unit do not address high head pressure. Reducing charge without analysis can create low suction or compressor damage. High condenser pressure during moderate ambient conditions is commonly caused by restricted airflow, foul condenser coils, or malfunctioning fans, which reduce heat rejection. Evaluating airflow and condenser efficiency ensures proper heat exchange, system safety, and compliance. Manufacturer specifications, preventing unnecessary component failure and maintaining optimal performance. Question 25. Throughout the course of restoring an HVAC system after minor chemical contamination, Ahmed notices residue near the compressor, which approach aligns with best safety and environmental practices. A. PPE, contain and clean the chemical spill and document the incident before system restoration. B. Wipe residue quickly and resume operation. C. Dilute the chemical with water while the system is running. D. Replace the compressor immediately without cleaning. Answer. Correct answer. A. Quick wiping or diluting the chemical ignores hazards and regulatory requirements. Replacing the compressor without cleanup risks contamination and system damage. Proper practice includes using appropriate PPE, containing and cleaning the chemical spill, and meticulously documenting the incident for compliance. This approach ensures personnel safety, prevents environmental contamination, and maintains equipment integrity, aligning OSHA and EPA guidelines for chemical handling and HVACR emergency response. Question 26. In comparison with a normal operating system, a refrigeration unit shows low suction pressure with frosting on the evaporator coil. Patel should first A. Verify proper airflow across the evaporator and check for blockages. B. Add refrigerant immediately. C. Adjust thermostat set points downward. D. Cycle the system repeatedly. Answer. Correct answer. B. Adjusting thermostat or cycling the system does not resolve low suction pressure. Immediate refrigerant addition without diagnosis risks overcharging and equipment damage. Low suction pressure with frosting commonly results from restricted airflow due to clogged filters, blocked ductwork, or coil contamination. Verifying airflow ensures proper heat absorption and prevents compressor damage, aligning with refrigeration cycle principles, practices, and safe diagnostic methodology for emergency response scenarios. Question 27. During the process of inspecting a commercial AC system, Mr. Robinson observes erratic compressor operation and fluctuating amperage. Which troubleshooting principle is most relevant? A. Measure motor current with a multimeter and compare to rated specifications. B. Replace the compressor immediately. C. Adjust the thermostat to stabilize operation. D. Cycle the system breaker repeatedly. Answer. Correct answer. C. Thermostat adjustments or breaker cycling do not address electrical or mechanical faults. Replacing the compressor without diagnosis is premature. Fluctuating amperage often indicates motor overload, electrical faults, or mechanical binding. Using a multimeter to measure current against rated specifications identifies the root cause, ensuring safe and efficient operation. This systematic approach aligns with ELEC troubleshooting best practices, OSHA safety standards, and advanced HVACR diagnostic methodology. Question 20. In the absence of proper system evacuation, a newly installed AC unit exhibits signs of moisture and air in the lines. Dyer should A. Pull a deep vacuum to remove non-condensables and moisture before charging refrigerant. B. Charge refrigerant immediately. C. Test system pressures at low charge without evacuation. D. Introduce ambient air to flush the lines. Answer. Correct answer. D. Charging without evacuation traps moisture and air, risking acid formation and reduced efficiency. Low charge testing or introducing ambient air introduces contaminants. Pulling. A deep vacuum removes non-condensables and moisture, ensuring proper refrigerant performance, extending system life and complying with EPA Section 608. Proper evacuation prevents compressor damage, maintains thermodynamic efficiency, follows standard industry protocols for system charging and startup. Question 29. Through the lens of ISTA Ahmed responding to a minor refrigerant leak in a display case, which action demonstrates regulatory compliance and safety? A. Isolate the affected area, ventilate, and recover refrigerant using certified equipment. B. Ignore the leak and continue operation. C. Open doors to dilute the refrigerant. D. Cover the leak with tape temporarily. Answer. Correct answer. A. Ignoring, diluting, or covering the leak fails to mitigate exposure and violates EPA Section 608. Safe handling requires isolating the area, ventilating, and recovering refrigerant using certified equipment. This approach protects personnel, reduces environmental impact, and ensures regulatory compliance while allowing the system to be repaired safely and effectively, reflecting best practices in refrigerant leak mitigation and emergency response procedures. Question 30. In an effort to diagnose high liquid line temperature in a walk-in cooler, one should first A. Inspect the expansion device for blockage or improper superheat. B. Reduce refrigerant charge immediately. C. Adjust indoor thermostat settings. D. Cycle the system power repeatedly. Answer. Correct answer. B. Adjusting thermostat or cycling the system does not correct the thermodynamic imbalance. Reducing refrigerant without evaluation can worsen low suction or damage the compressor. High liquid line temperatures are typically caused by expansion device malfunction or superheat misadjustment. Inspecting the expansion device ensures proper refrigerant flow, optimal heat absorption, and system efficiency, aligning with refrigeration's principles and industry best practices for emergency HVACR troubleshooting.